In the solar industry, it is generally assumed common knowledge that a system like this, where you have rapid shutdown devices, in this case, an AP Smart 2-to-1 RSD, I don't know what the model is, but those things, that you cannot curve trace these systems. But I don't think that's true anymore. I have yet to test this, but this AP Smart RSD start kit theoretically lets an entire string's worth of voltage pass through it. You have your inputs here where you put your string voltage, you have your output here where you put your curve tracer, and bada bing, bada boom. We're actually doing commissioning for a third party on this site. We didn't build this site, we're just making sure everything works properly and is safe to turn on. And in prep, our customer bought one of these. They found this, bought this. This may have existed for forever and I just didn't know about it. So this might be old news to a bunch of you, but I also haven't seen anybody talk about it. Their assumption was that in order to do proper voltage testing for each string to make sure that all the panels got properly connected, that you needed one of these to be able to turn on the string of panels to be able to properly test the full string voltage. Now, in practicality, what I've done most of the time when commissioning an inverter like this, I actually turn the entire inverter on, and before it hits its production cycle, I go through each fuse individually, close each individual fuse, and voltage test just on those strings, which works fine. It's annoying, but it's fine. It works totally fine. And you could theoretically curve trace the same way, but I don't know. I don't know how much that might mess with the inverter. I'm not as familiar with the super technical bits on that front, but I guess theoretically it's possible. This, though, definitely should be possible. But why can't we just curve trace through a line of rapid shutdown devices? Well, in order to turn on every single one of these devices, they need to be seeing a certain signal pulse going through the line. And in order to do that, you need to have a transmitter and you need the circuit to be closed enough to allow that signal to go through. No curve tracer out there has that transmitter built in, nor does it have that pause of after connecting the circuit to allow that pulse to travel through and turn on all of the rapid shutdown devices. I mean, you could do it, but from, say, Fluke's perspective, I'd imagine that you are building a product for a single manufacturer's device, which makes that a difficult business proposition. Even though all of the, AP Smart, Tigo, Sunspec type shutdown devices basically all use the same type of pulse to turn on all their devices, not by the instruction manual does it do that. I feel like it would still take a lot of work and coordination to make sure that the most amount of devices work with something like that. Plus it's added complexity. I get why they don't do that. But without that transmitter and without a way to close that circuit, you can't do it. You just can't. You're gonna get 10 volts and that's it, right? So let's hook this thing up, see if we can get it to high voltage, see if we can get a good curve off of these things, and then we'll take a look at the innards of that start kit and see what makes it tick. Probably the best way to go about this is to unland the string we'll plug into these connections here, and then you need a power source. The start kit does come with a battery pack that is basically just 8 AA batteries, whatever works, and an on-off switch. We're gonna keep this unplugged for now until we get everything connected. So we're gonna actually test F12 here, because F11 is on another array. And the fun thing about a string being on another array that's already producing is that you can get crosstalk between strings. So if you have a string that's running alongside another several strings that has the power on signal on them, these strings can pick that up too, just inductively. Magnetic fields, man. We're gonna wire nut these on here, and we'll get our other wire on here. Okay, now we should, before turning this on, have proper polarity and rapid shutdown voltage. There we go. actual solar leads. Those in there. And we have, hard to see in the sun, but it is 10.1 volts. We have that going through. So if I add power, we should go from 10 volts to, there we go, 611 volts. I do believe that's full string voltage. So let's try playing with the IV curve setting here. I don't have my irradiance meter out yet. I'm just gonna try a curve with my current settings, which are gonna be totally wrong, but we'll get a curve. We'll see what it looks like. If it decides it's going to, wait. Okay, there we go. Oh, that looks like that might, yeah, look at that. Boys and girls, that's a curve. Yeah, that's pretty sick. Oh yeah, obviously it doesn't have sync with my irradiance meter because I didn't set it up, but you know what? Let me go do all that and actually run a proper curve so we can see what it looks like. So we are at a very respectable 573 watts per meter squared. That is fine curve tracing weather. And I just gotta set up the meter. 53 fill factor. I gotta look that up because I can never remember how to calculate fill factor. So I think we got our module information put in here okay. How many modules in these strings? 12. And only one string in parallel because we're just, yep. All right. So now we're ready to run a real curve trace. Our irradiance meter is connected and very happy. Of course, it includes your tilt with your irradiance and your temperature. And we run test. It's got our fill factor window there. And this curve is starting off really low because the irradiance is not even close to standard test conditions, but it's going to adjust that after the fact. All right, it thinks it likes it. Pass criteria is set at 15%. Once adjusted for STC, I can never remember exactly how to read this. Yeah, so once it's adjusted to bring it up to STC values, like if it was bright enough and if it was warm enough, given these voltage readings, this would be what it would look like. So that's well within our 15% tolerance there. So what happens? Let's bring our tolerance down a little bit. So these are brand new panels. Let's run it again. Sorry, now this is becoming a curve tracing video. I'm all right with that. Okay, there it didn't quite fare as well. Oh, but it's real close. It's super close. That's pretty darn good for, yeah, that's pretty darn good. Ladies and gentlemen, that is the first time that I've curve traced a rapid shutdown system. That's very cool. Let's take a look at what's actually in here to see what is actually allowing this to happen. I suspect you can probably build one of your own of these, but let's take a look. Of course, we've already seen our battery pack. It is 1, 2, 3, 4, 5, 6, 7, 8. AA batteries, that's literally all it is, with an on and off switch. And then with just a DC connector on the outside, plugs into this part of the APsmart. And we just got a few screws here. And inside, we see that this power cord goes directly to the transmitter. This is just the APsmart transmitter. Any rapid shutdown device that you use that isn't an optimizer is probably gonna have one of these in the inverter somewhere. You can even look in this inverter. This inverter has one too. Some of them are visible, some of them aren't, but you'll see these around. You can also just buy these directly, build your own transmitter box. Works fine. What is that about? Oh, that's a light? Oh yeah, that's just a light. Ha! I guess that's just fiber optic. That's funny and cool, and I didn't notice that. Got a light that goes there. I don't know if you can see it. It's pretty dim in the light of the day, but there's a signal light. It's just like a little fiber optic cable strung to the outside. That amuses me and delights me greatly. Anyway, so you turn it on, turns on the transmitter. The transmitter goes to this coil here, which is zip tied to one of the voltage cables. It can be either one, really doesn't matter. But the one thing, the secret sauce that I've been curious about for so long is this thing. I believe that is a capacitor. It is a 0.47 microfarad plus or minus 5%. I guess it's good for up to, I am terrible at reading electronics terms because I don't do electronics very much, but all this is a capacitor. You could probably get one, solder it onto the lines just like they have. Like, this is not even like a really fancy solder job. It's just solder. And all that this is doing is this is what is closing that circuit to allow for the modules to get that pulse through that closed circuit. Because once that circuit's open, that pulse does not go through those wires anymore. You need a closed circuit. So this is allowing the circuit to be technically closed without allowing it to run a short circuit or run actual power through the circuit. So you could literally buy one of these capacitors, build this box the same way, and make your own transmitter, your own curve tracing box with any transmitter that comes out. It could be Tigo, it could be AP Smart, it could be Sunspec. If you have a system you want to curve trace and the inverter's got a transmitter, or you know the brand of the RSD, grab that transmitter, grab yourself a capacitor and a coil, make yourself a box. Pretty sweet. Hey, thanks so much for watching. I am the Solar Boy. My goal is to make solar as accessible to as many people as possible in terms of understanding the technical bits of how things work. I take a look at old systems and how they fail, new systems and how they could be built better, and I appreciate having a nerd like you make it this far in a video about curve tracers and rapid shutdown. Now, if this is a topic you're interested in, I do want you to go check out my website, the 3741 reference, because I'm a well-documented advocate of UL 3741, which is an option aside from doing rapid shutdown devices, which takes a lot of devices on the roof and creates a lot of failure points. UL3741.com is where you go. And I have listed there all the products that you can use that are rated to work together in order to create just as safe a system as one with rapid shutdown devices, but without the rapid shutdown devices. Aside from that, if you'd like to subscribe, I'd very much appreciate it. Share this with somebody that you think would enjoy it, and until next time, stay shiny. I'm getting better at not cringing at my catchphrase.
Takes practice.
It does.
I like it.
Yeah.
Stay shiny.
Stay shiny. It's a good. I like it too.